What I want to talk about in this segment are characters and strings, which is the way we represent textual information inside Haskell. A character is a single letter or digit, and a string is a sequence of these things. And this is how we can communicate meaningful information to a human reader of output from a program. The way we write characters is inside single quotes. So single quote digit 1, single quote character A, single quote semicolon, etc. The way you write strings is inside double quotes. So double quote integer, closing quote, double quote A, closing quote. Now that's a different thing from a character. That's a string that happens to have just one character in it. And that's different from the character itself. Before we go on to say anything else, I'd like to talk a bit about how Haskell deals with some of the standard definitions that it supplies. There's a module called the standard prelude, and that contains definitions of commonly used types and functions. And that's automatically imported into GHCI and into every Haskell module. But there are other library modules which are separate from the prelude, which if we want to use the functions from that module have to be imported using an import statement. And we've seen some examples of import, in fact, in modules we looked at earlier in the course. So the module Data.Char is the module that contains all the interesting functions that work over characters. And if you want to see what's in a module like Data.Char, you can type :browse Data.Char, and what that will do is print out the types of all the functions in that module. But let me just run through a few of them, the crucial examples in my view. So first of all, there are functions chur and ord, which convert from an int, fixed size integer, to a character, and from a character to an integer. And what those things do is that they turn the ASCII code, American Standard Code for Information Interchange, numeric code into a character, or turn a character into its standard code. And if we want to write some functions by hand that, for example, turn a small letter into a capital letter, we can do that by turning the character into a code, adding an offset that converts it from small to capital, and then converting back into a character. So that's typically the way that those things are done. But in fact, in Haskell, you don't need to worry about functions like that because they're all predefined in Data.Char. And there are two classes of things. There are conversion functions like to lower and so on that will convert a capital C into a small c, for example. But more usefully, there are functions which will distinguish or discriminate between different kinds of characters. So the function isDigit will tell us whether a character represents a digit. Is it 0 or 1 or 9, or is it something entirely different? And so there's a whole range of those conversion and discrimination functions in Data.Char. And if you type :browse Data.Char, you can see them listed. And it's obvious what they do from their name. So that covers the main purposes of characters. All I wanted to add to this was to say, of course, any notation you have, for example, using single quotes to denote characters, how do you denote the character single quote? And so we have what are called special characters, and they get denoted by putting a backslash at the beginning of the character description. So \n means new line, \t means tab, backslash means backslash single quote means single quote, and backslash double quote means double quote. And having those special characters means that we can write strings that contain double quotes or single quotes or tabs or new lines or whatever, which it would be difficult to do were we not to have that special way of writing a new line or a tab, etc. So we use those to build up, typically to build up strings that contain new lines, tabs, or quotes. Now, I talked about strings. Let's look at how we write them down. As I said, what we do is use double quotes, and between there we put the characters. So integer or a string with just a in it. And one of the operations we can do on strings is to join two strings together. And to do that, we use the plus plus operation. So if we join the string hello, comma, space to the string world, exclamation mark, we get the string hello world, exclamation mark. Now, in fact, there are loads of functions over strings because strings are just a special case of lists, and there are loads of useful functions over lists. So I'm not going to talk any more. I think all we need for the moment is a mechanism for joining two strings together. But all we need for the moment is that. And so we'll come back. If we want to do complicated string manipulations, we'll do that once we've learnt about lists. Now, the main purpose for us at the moment of strings is strings are the way that we make printable, that make readable the results of an evaluation. And the way that's done in Haskell is to use a show function. And so printable data is shown is by applying a show function to it to turn it into a string. Now, one thing you need to be aware of is that you can't show everything. And in particular, if you try and print out a value which is a function type, you will get an error message from GHCI. And that's because that function types can't be shown, can't be rendered visible, as it were. Now, I'll talk in a moment about what those error messages look like and how we start to unpack them. But I wanted just to warn you, we're going to come on to that in shortly. So we'll have a big session about error messages, but we also need to talk a little bit more about overloading. But before I do that, I want to talk a bit about floating point numbers. So that will be the next segment.